Hello students, I am here with another video from the chapter Light, Reflection and Refraction from class 10th NCERT book. Before starting today's video, I would like to tell you all that till now we have discussed about the first part of the chapter, that is reflection of light. So in reflection we discussed the topic, that is what is reflection. Then we discussed about what is the phenomenons of light, the characteristics of light. After that we discussed about the types of the reflecting surfaces, in which we discussed about mirrors and lenses. So in mirrors we saw that there are two types of mirrors, and in which concave and the convex mirrors properties were discussed, and we also discussed about the image formation using these curved surfaces, that is the concave mirrors and the convex mirrors. Then after that, in the last class of that reflection part, we discussed about the mirror formula and the magnification. Similarly, after that we discussed about the refraction part, where we saw that light is going to bend when it is moving from one medium to another medium, which is from optical rarer medium to optically denser medium. Similarly, we have discussed about the refractive index, and then we saw that there are two laws which is being related with this with the properties of these refraction. So the first law and the second law we have discussed, and after that we saw the ray diagrams which is related with the formation of the images in the convex and the concave lenses. So we discussed about lenses also, its uses and its properties, and lastly in the last class we discussed about some of the uses of these concave lenses and the image formation in concave lens, and then we discussed about the uses of the concave lens in the previous video. Okay, so in today's video I'm going to discuss the remaining topic which is left in this lesson, that is the sign convention in the in the spherical mirrors. Okay, yes, spherical mirrors, the sign convention also I have discussed to some extent, and today I'm going to extend the video related to this sign convention and how we are going to use this sign convention and how we are going to derive the lens formula similar to that which was in the mirror formula. Okay, so we begin with the chapter. We begin with this today's video by the first slide, which is going to tell you about the lens formula and the magnification. Now what is this lens formula about? Let us discuss. So this lens formula means it is the relationship between the image distance, object distance and the focal length. Okay, now we discussed about the image distance, object distance and focal length in very much details in the last videos. Okay, then we saw, then what is this magnification? Again the formula remains same as it was there in the mirror formula, that height of the image upon height of the object, means it is the ratio of the height of the image with the height of the object. Okay, now before that, what is this how is this lens formula going to be used? We can see from this part that whenever we are using these sign conventions, how can we find out the distance of the light when it is at the right side or on the left side, and when the object is placed perpendicularly upwards towards this principal axis, and then what will be the sign of the image which is formed downwards from the principal axis. Okay, so in this manner we have seen that whenever we are keeping the object on the left side of this mirror, the left side of this lens, as we are talking about the refraction, will deal only with the lenses. Okay, so we will see that the distance which is in the left side of the lens is always in the negative, with the negative sign, and the distance which are kept on the right side of the lenses is known as the positive. It is always kept in the positive symbol. Okay, similarly whenever the object is placed at the which is perpendicularly upwards, it is always in the positive sign, and whenever the image is forming downwards, so such images will always be taken as negative. So this was about the sign convention, and then this lens formula will be used accordingly to this sign convention. Okay, now again we will discuss about this magnification and lens formula in details with the next slide. So this slide is telling you about what is this magnification. So magnification is M. It is denoted by the letter M, and it is the ratio of the height of the image upon height of the object. It is the similar part which we have discussed in the last class also in the case of the mirrors. Okay, so this magnification is always taken out by the image. It is the ratio of the image of image height upon object's height, okay, or the image distance upon object's distance. So this magnification is always written, it is the length over a length, okay, means it is going to be the length of the height of the object, means it is the height of the object where it is being kept in front of the mirror, and then what kind of image we are going to obtain, the length of that image will also be compared. So we are comparing only the lengths of an object with respect to its image formation, okay. So it gives you how much magnification power a lens has. So what is this magnification? Magnification means it is the power of any lens, which is going to tell you about that how much dimension, how much is going to this lens is going to give you the what is the extent of this lens, which is going to give you the type of the image, okay, whether the image formed will be a very smaller one, or reflected or the image formed will be a larger one, or it could be a very diminished part, okay. Similarly, here the rule could also be changed if u and v both are given. So height of the image upon height of the object would also be written as m is equal to v by u, okay. So this was all about magnification of lens. Now next thing is that what is the power of the lens. So power of the lens is always discussed. It is the reciprocal of its focal length. What is this power of the lens? It is the power means what is the use, I mean how much strong is that lens is. Yes, so power of the lens is the reciprocal of the focal length, that is 1 by f. What is the power? How power of the lens is measured in the degree of convergence or divergence of the light falling on it. Means what amount of light whenever it is falling on a concave lens or a convex lens, what will happen, how much the power is going to be converged with this convex lens, and how much the power is being diverged from this concave lens. This is what is told about the extent, the measurement. It is the measurement of the degree of, okay, it is the measurement of the degree of the convergence or the divergence of any lens. Whether it is if it is a concave lens, it will be the divergence power we are going to measure, and if it is a convex lens, then we are going to measure the convergence power. So what is this power about? Power is the degree of these light rays which are falling on it, how much it could be it is going to be converging or it is going to be diverging, okay. If the convex lens is there, light is going to fall, and on wherever, as if the concave lens is there, then what happened, it is going to diverge the light falling on the these types of lenses. So if convex lens is going to converge a beam of parallel rays, if suppose that if a convex lens is there, it is going to converge the parallel ray of beam to a point, okay. So if it is going to be there, it is going to supply these light rays are going to be more strongly focused them closer to the optical center. Means it is said that greater power of the convex lens which focuses the same parallel rays at a greater distance from the optical center, okay. Now what happens about the concave lens? Similarly, in the concave lens, which is going to diverge the parallel rays of light, it is more strongly said to have a greater diverging power than that of the concave lenses, which diverges the lens, which is going to diverge the light rays less strongly, okay. So that is why it is going to depend, means this power is going to depend, it is going to be inversely proportional to this focal length. If focal length is less, the power will be more. If power is less, then focal length will be more. It is going to have an inverse relationship with this focal length, and it is dependent upon what kind of focal length these lenses are having. If convex lens is there, it is going to have the positive, means this power is going to have positive and the negative symbol, because this positive and the negative sign is going to tell you which type of lens we are using. Now as it is a unit, it is a degree of the measurement of something, it means it will be having an SI unit. So the SI unit of this power of lens is always denoted by this diopter. It is always measured in diopters, and it is the power of the lens, and it is denoted by the capital letter D, okay. So this is always denoted by D. So what is this? 1 diopter? 1 diopter is the power of the lens whose focal length is almost 1 meter, okay. So what is this diopter? Please remember, this diopter is the measurement, it is the SI unit of the power of lens. Next is this focal length is always measured in meters. That is why because it is a length, that is why power becomes 1 by f. Or if we need to take out focal length, then it could be in the reciprocal form 1 by p. So it is always measured in diopter d, and 1 diopter is always the power of the lens whose focal length is 1 meter. So what is the definition of this diopter is going to tell you about a lens which has the focal length of about 1 meters. Now what about the positive and the negative symbol? So this positive and the negative symbol is going to tell you about the type of lens. So the convex lens will have a positive power, whereas the concave lens has the negative power. Why it is having a positive and the negative power? Because it is directly proportional. These convex lens have a positive focal length, that is why this has a positive power. Similarly, a concave lens is always having a negative focal length, that is why this is having a negative sign. Okay, so this focal length, it is going to depend upon the type of lenses which we are using. Fine. So that is why we are going to use the units according to the definition, according to the way of lens which we are using. If it is a positive lens, it means it is always a convex lens, and if it is a negative symbol is written, it means it is a concave lens. So please remember what is the reason behind this putting a negative and a positive sign on the power of the lens. Okay. Similarly, with this, the chapter is complete. From this light chapter is complete. We have all seen about the reflection and the refraction of light in this chapter. We have discussed much about it. Now it is the time to solve some numericals which is related with this chapter. Okay, now the first numerical, so some of the numericals I have taken from your NCERT book, and others I'll be giving it in the from other books I have taken. So from this first numerical which you could see here on the slide is of your NCERT book. So what does it say? So it is going to say that the question is a concave lens has a focal length of 15 centimeters. At what distance should the object from the lens be placed so that it forms an image of about 10 centimeters from the lens? Okay, now what and also need to find out the magnification produced by the lens. So what solution you could observe? That a concave lens always has a virtual erect, and it is always formed on the same side of the object. Okay, so this is the property of the concave lens which we have seen earlier, that whenever an object is kept, it is always in the virtual erect position. Okay, so the image distance is equal to minus 10 centimeters, and what about the focal length? It is of minus 15 centimeters. So what these two things are given to us in this numerical, that we are provided with the image distance, that is v, that is minus 10 centimeters, and we are given with u, which is means we are given with f, not with u. It is given with f with focal length of 15 centimeters. It means the focal length of a concave mirror is always in the negative side, so we are going to take this in 15 centimeters. Okay, so next is that after using this, we need to find out the image distance, object distance u. We need to find out u. So for finding out u, we need to use the lens formula, that is 1 by v minus 1 by u is equal to 1 by f. Okay, so we'll just find out 1 by u. We are going to get it as minus 1 upon 30. Okay, so this u will be u is going to become minus 30 centimeters. Okay, so this is how we are going to get the object distance as at 30 centimeters. Now what about magnification? You know that the formula for magnification is it is the object distance upon the image distance. So what was the object distance? Image distance upon, it is the ratio of the image distance with respect to the object distance. Okay, it is v upon u. So what was v? It was 10 centimeters, and upon v, what is this u? This is 30 centimeters. So we get 1 by 3, or it is plus 0.33. So as it is a ratio, so it is not going to have any unit, that is why its magnification becomes 0.33. It is its magnification. So the positive sign is going to show that the image is always a virtual erect, and the image is 1/3 of the size of the object. Okay, it is erect and it is virtual image. Okay, so this is all about the characteristics, and this is how you are going to apply the sign convention in the numericals. So this was the first numerical. Now I move on to the next numerical, which is also from your NCERT book as example number 10.4. It is given there. So the question is like this: a 2 centimeter tall object is placed perpendicular to the principal axis of convex lens of focal length 10 centimeters. Okay, the distance of the object from the lens is 15 centimeters. Find the nature, position and size of the image, and also find its magnification. So this is about what we need to find out. First we need to find out what all things are given in the question. So we have the height of the object, that is h, that is plus 20 centimeters. Okay, I mean sorry, it is about 2.0 centimeters. Okay, next what we are given with, we are provided with f, that is about plus 10 centimeters. Why it is plus? Because the lens which is here is the convex lens. Okay, next thing is that we need to know, we also have the object distance, that is u, that is minus 15 centimeters. As the object is always kept on the left side, we will always have the negative sign. Okay, so that is why in the lens we will always have the negative symbol. So what will happen to the height or the image distance will be v, it is not known, and h also is, h dash is also not known. We don't know where is this image going to form and what will be its height. So we are going to find out first the image distance, that is v. So we are going to use the lens formula, that is 1 by v minus 1 by u is equal to 1 by f. So 1 by v is equal to 1 by u plus 1 by f. It means 1 by v becomes 1 upon 30. So plus 30 we are going to get. So what is the meaning of this plus positive sign 30 centimeters? So this positive sign is going to show that the image distance is of 30 centimeters and in the other side of the optical center. It is formed on the other side of the optical center, means somewhere here. Okay, so we are going to get the image which is inverted. It is real, it is inverted, and it is also on the opposite side of the, it is on the other side of the optical center. So this is about the image, it is about the characteristics of image which we have obtained on this convex lens. Okay, now what about magnification? So when we need to calculate the magnification, what we are going to do, we are going to just see what all things we are provided with, and then we are going to write down the formula of magnification, that is m is equal to h dash upon h, and v, and that also becomes v upon u. Okay, so h dash is equal to h v upon u will be in the bracket. So height of the image will be obtained using this formula. Okay, according to which we get magnification is about 30 upon minus 15. What is this 30? 30 is the image distance, that so the image distance is, we have found that it is plus 30 centimeters. Okay, so we are going to keep it as numerator, that is plus 30 centimeters. After that divided by minus 15 centimeters. Okay, why minus 15? It is the object distance. Okay, so this was already given in the question, and we get the magnification as minus 2. Now this minus sign is going to indicate that the image is inverted and real, and it is formed below the principal axis. Thus the real inverted image, that is 4 centimeters tall and is formed at the 30 centimeter of the other side of the image of the lens. Okay, so that is why the image will be 2 times enlarged. So this image will be 2 times enlarged than that of the object. That is the magnification power. It is twice that of the it is twice to the object height. Okay, so this was the second question, and now we are going to get the third numerical, which is written here on the next slide. This numerical says that an object of 5 centimeter in length is held 25 centimeters away from a converging lens. What is this converging lens? Converging lens means it is talking about the convex lens. So this converging lens of the focal length of 10 centimeters. Now you have to draw what is the focal length. It is 10 centimeters. Okay, next we need to draw is the diagram which we need to draw is ray diagram, and to find out the position, size and the nature of the object, nature of the image formed. Okay, so what all things we are given here, it is if the height of the object is given as plus 5 centimeters. Okay, it is already given. Then we need to we have to know about the other things what is given in the question. Okay, now why this is positive 5 centimeters? It is positive 5 centimeters because it is placed on the above the principal axis. Okay, so object is always placed above the principal axis, that is why it is always of positive sign. So a 5 centimeter object is placed. Okay, so this is kept on in front of the lens. Now where it is being kept? It is kept in front of the lens, hence the object distance will be in negative. So the object distance, that is u, is minus 25 centimeters. Next we will get why it is minus 25 centimeters, as this object is object distance is also, we are going to measure it on the left side of this of the principal axis, that is why we will always measure in the negative symbol. Now the converging lens is a convex lens, and since the focal length is always positive, so this focal length we are going to consider it as 10 centimeters. This is always taken as the positive, with a positive sign, as it is a concave, it is a convex lens. Okay, so all these points should be kept in mind, please remember this. Next what we need to do is we have to find the position of the image. Now the position of the image means we need to use the lens formula, so we need to find out the distance of the image at which it is being formed. So we need to find out v. So using this lens formula, 1 by f is equal to 1 by v minus 1 by u. So 1 by f plus 1 by u is equal to 1 by v. After, we are going to just shuffle this formula and we are going to get this. Fine. Next we need to find out 1 by v. We are again going to use this formula according to our situation. Next it is going to get, we are going to get 1 by v, and we are going to substitute 1 by f as 1 by 10, and 1 by u will be substituted as 1 upon minus 25. Why we are taking minus 25? Because it is already given in the question that object distance is 25 centimeters, and since it is the object which is placed on the left side of the lens, that is why we have taken it as minus 25. Now after solving this, we are going to get the answer for 1 upon u. 1 upon v we get as 50 upon 3, that is 50 upon 3 centimeters. We are going to simplify it and we get it as v is equal to 16.7 centimeters. Okay, now hence the image formed is 16.7 centimeters on the other side of the lens. Now please remember that how we are going to use these informations which is given in the question. Okay, so we got the hints from the question that it is a convex lens, it is a converging lens, and what kind of focal length it might be having, what is the image distance, what is the object distance. All these things will be taken out from the question itself. So we found that what is the position of this image. Before that we need to find out v. We have found this value is 16.7 centimeters on the other side of this lens. Okay, it is on the other side of the lens. Next, what will be the finding of the now what next we need to find out? We need to find out the size of the image. So how can we find out the size of the image? So for that we need to assume that the height of the image is h dash. And what about, and how is we are going to use this? As we know, the formula for magnification of the lens is v upon u is equal to image distance upon object distance. Okay, and similarly we also know that magnification is equal to h dash upon h. Now this h dash is the height of the image. Okay, so we can equate these two equations, that v is upon u is equal to h dash upon h. So what we are using this here, because we don't know what is the value of this h dash, so there is none other way, as we have not provided with the magnification also. So we need to find out, we need to take out the values of the height of the image according to the situation, according to the question which is given there. So we have got v, we have got u, and we have h. Okay, so we can find out this h dash by equating the equation v by u is equal to h dash upon h. So we have kept the values of 50 by 3 that we have got just now here, 50 by 3, because if we are going to keep 16.7, it will be a calculation will become quite tough and we need to calculate more. That is why we are using the fractional value only. So this fraction was 50 by 3, which is v, and upon u was minus 25. Okay, so you could see here that u is minus 25, which is given here. Okay, next what we need to do is we need to get h dash. So how we are going to find this h dash is we are going to simplify this and we are going to find out this h dash. So this h dash is 50 by 20, means here we will cross multiply and we are going to solve. So after cross multiplying we get 50 upon minus 25 into 3 as denominator and is equal to h upon 5. So we have substituted 5 here, as we know that height of the object was plus 5 centimeters. Okay, so we got it as, lastly h dash was minus 10 upon 3. Okay, so the height becomes minus 3.33. okay, so this is in centimeters, it is the height of the image. So this is how we are going to get that height of the image is 3.33 centimeters. Now what does this negative sign indicate? This negative sign indicates, this negative sign which we are getting, it indicates that it is going to form below this principal axis and it is an inverted image. Yes, it is an inverted image. Now where we are going to get, either here this side, or we are going to get this side. Now we will find out more things, that the height of the image is 16.67 on the other side of the lens. It means it is present on this side of the lens. That is why it is always used in the negative sign, and it is a inverted image, and it is a if it is formed on the other side, it means it is a real image. Okay, so it means it is a real image. Okay, now real and inverted and diminished image. Why diminished image? Because size of the object is 3.33 centimeters and image formed is 16.67. it means that the image is formed on the other side of the object. So the diagram looks like this here. Okay, so the image formed is 16 centimeters. It is from 16.67 centimeters and it is in below the principal axis, so it is real and inverted. Okay, so how we need to draw the diagram? We all have the you all know how you are going to draw the diagram. You will take one lens, that is converging lens, then you are keeping an object here. As you know, the image this height was 5 centimeters. Okay, and this was 10 centimeters. This focal length was given as 10 centimeters. As you can see here, this f1 was 10 centimeters and this is 2f, means this is center of curvature. And what is the center of curvature? Means it is 25 centimeters. If it is 25 centimeters, means it is double, more than double. It means that double means 20. If it is 20 means we are reaching the center of curvature. Please remember this. How we are going to find, how we are going to keep the how we are going to use the data which is being given here. So we know that the object is somewhere beyond the center of curvature. How? As you know that f is 10 centimeter, this focal length was 10 centimeters. Okay, and if we going to if we are, and the object distance was 25 centimeters, remember that. So if it is a 25 centimeter object, it means from here, if we are doubling this 10 means it is 20, it means this is center of curvature, or you can write it as 2f1. okay, or after that what happens, this it is beyond the center of curvature also. So this means that plus 5 centimeters, it means the height, the distance is 25. 20 plus 5 centimeters more, so it is beyond the center of curvature. Remember this, how we are writing. Then this height of the object is 5 centimeters. Now again we are going to use the same formula, same rules. The image is the line coming parallel to principal axis is going to pass from the focus of the convex lens. Similarly, the ray of light passing parallelly to this optical center, crossing optical center, it is always going to cross directly, as it is not going to be converged or diverged at all. So the point where it is going to be this image is going to form will be just below this center of it is below the principal axis. And what about the height and the image which we are getting is 16.67. so this image which we are getting is 16.67 on the other side of the lens. So we will just mark it as we are writing this. So it is just 10 means this focal length will be 10, and then if center of curvature means, if we are writing center of curvature, it will be 20. So it is less than 20, it means it is 16.6. so it means it is lying somewhere in between the focus and the center of curvature. please remember how to solve these ray diagrams question and how you're going to draw the ray diagrams correctly. So in this ray diagram, it's very simple to know that how you're going to draw it. I have told you the trick that if it is focal length is given, it is just double the focal length, we get the center of curvature, and it is more than center of curvature, it means it is beyond, the object is always kept beyond the center of curvature. Fine. So next thing which we will discuss is next is the how next yes, and then what about the image part? Image part is that the 16 centimeter 16.67 centimeters we are getting. Okay, so 16.67 centimeters if we are getting, it means that the image distance is the image which is being formed is just double this focus. Means you could say that if it is 10 centimeter as the focus, and if we are going to double this focal length, it becomes 20. It is not 20, it is just less than 24 centimeters less than 20. It means that somewhere in between the focus and the center of curvature we are obtaining the image. So it is very easy to find out how this image, the direction of the image will be there. Okay, and if you remember if you remember what we have seen as a characteristic of the image which is being formed when the object is kept beyond the center of curvature, beyond this 2f1, in the case of convex lens, we will come to know that the image which will be formed will be diminished, real and inverted. Okay, and so this is why this is the reason why I told you to remember all those reasons, how all those characteristics which we obtain in the image formation of the various lenses. Okay children, so we found that we have solved this numerical in this way, and there will be you need to practice some more numericals so that it will be a practice for you all and how you are going to solve these kinds of numericals very easily. Okay, so this was about today's video, in which we saw that what is the magnification of the lens, and we will and we have also seen the lens formula, which is same as to that of the mirror formula, and it is the relationship between the image distance, object distance and the focal length. Okay, so that was very much similar to the mirror formula, and this formula is going to give you a relationship between the image distance, object distance and the focal length. Okay, so 1 by v minus 1 by u is equal to 1 by f. Similarly, we have seen some of the numericals and how we are going to solve these kinds of numericals if it is going to be asked in the question that if the image distance is given, if the object distance is given, if the height is given, and how you are going to draw these array diagrams according to the question which is being provided. So that was all for today's video children. I will meet you all in the next video with the next topic to be discussed. Thank you for watching the video.